Hey guys, and welcome to part 2 of our 3-part Exponent series. This is especially targeted for chapters 4 and 5 for Math 10C in the Alberta curriculum. This is also helpful for those who just want to learn about negative exponents, as that's what this video will be about. So watching the previous one about the basic exponent laws would have been quite helpful for this one. But today we'll be focusing mainly on negative exponents. So, firstly, before we're going to start anything, I want to clarify what a reciprocal is, since that is more or less the key to negative exponents. So, x. How could we represent x as a fraction? Well, whatever number x is could be represented over 1 as a fraction. Okay? What would be the reciprocal of this? Well, the reciprocal of that would be 1 over x. And how did we get that? We moved the 1 up there, we moved the x down here, we kept the sign equal. Okay? So, yeah, that's what a reciprocal is. Okay? And clearly, the value from here, if x is a positive integer, or really positive anything, let's just say if x is a positive integer in this case, this value should be ideally lower than this one. By should I mean it will be, unless we start going to negative numbers and stuff. But yeah, anyway, this is used in division of fractions, so you need reciprocals to change it to multiplication for for simplicity's sake. But it's also very, very important in negative exponents. So let's start off with 5 to the power of negative 2. So what are we going to do here? Well, quite simply, we're going to take the reciprocal of this number, and that will erase the negative, okay? So, the reciprocal, sorry, not the reciprocal of this power, the reciprocal of the base. Okay, don't do the reciprocal of the power, okay, point is, take the reciprocal of the base, and like I just said, any number could always be represented over 1 to be a fraction. So, what we can do is take the reciprocal of that, which will be equivalent to 1 over 5. And this negative 2 just doesn't disappear. It actually sticks with the 5. So this power will stick together throughout your expression. Okay? This negative, on the other hand, will actually be erased here. So we get 1 over 5 squared, which is also equivalent to 1 over 25, which is a very fractional number, of course. That's 1/25th, or 4% could also be expressed as. Okay, so second rule in negative exponents is how could we represent this as a power with a single base? Yeah, okay, so that doesn't seem very possible. You would add them if these bases were the same, and they clearly aren't. So what do you do? Well, what you can do is we always do this, right? Since we're going to take the reciprocal of 8 over 1, okay? Reciprocal of that, which is going to give us 1 over 8 squared, since once again the negative gets erased and the exponent sticks with the base. Okay, while 7 will remain 7 squared over 1. This is an interesting fact. These two can multiply, and those signs can merge. So, 7 squared times 1 is 7 squared, and 8 squared times 1 is 8 squared, right? So we get that. This can furthermore be expressed, like I said, as a single power with a single power. Okay, sorry, anyway, this we could actually take those out, and put brackets around, right? So it'll look like this. And now we have a single power with a single base with a single exponent. Yeah. So, yeah. What about this? Yeah, if you were given that on a test, and once again, these are really basic questions, so these are so procedural. They will definitely mix this in with some useless wording in there, like, oh, someone is painting their fence and they need this and that, and the point is just grab the numbers out. Anyway, so if you're given something like this, how could we change this to a single power? Well, we could take the reciprocal of that. Except, notice this. That has a 1. Okay? That has a 1. Now, this one we will ignore since we only need this one for this case. Okay? So, if we take the reciprocal of that, what we'll actually get is 8 to the power of negative 1. Yeah. So, that's a single power right there. Okay. Now, for the expert question. Let's see what you can do. Feel free to pause the video right now and try this question out for yourself. If not, I will show you how to do it. And yeah, so let's get into it then. Well, first thing we need to notice is all of these are negative exponents, and we are going to need to reciprocal all of them. Okay. Except, this is already a fraction for us. This is 16 over y and x over y. Okay? Notice that. So if we were to take the reciprocal of this base, what would it look like? Oh, by the way, I'm simplifying this to its maximum extent is what the question would ask. Please simplify this expression to the maximum extent. Anyway, so we start off by reciprocaling everything, okay? Which would give us y to the power of 4. Wow, that is okay, y to the power of 4 over 16 squared times x to the power of 4. Okay, and we're done. No, we aren't. We need to simplify it even more so. Now, here is something that is a little interesting. As we already know, this would be equivalent to y to the power 4. Am I right? So we could actually express it like that, and nothing would be wrong with that. Okay. Just note that. It's very, very important, especially for this case. So, we're going to express y to the power, y squared times y squared over 16 squared times x squared squared. Okay. Now, notice we have the exponent of 2 here, exponent of 2 here, exponent of 2 here. What could we do with that? Well, we could take the square root of that, right? So we would go y squared is 16x squared, except we're not done, since 16 is a perfect square. So we can actually square root that again and get ourselves y over 4x yeah, and this would be multiplied by itself 4 times. Yeah. So that would be as a single power with a single exponent. Yeah. So, oh, by the way, we should probably add the fact that that is already being squared. That's why we got the 4 there. So, from here to here, we get a 2. from here to here, we get an additional 2. Sorry, we actually square that 2, or multiply that 2 by itself, which is 2 times 2, which gets us 4. Okay? And yeah, so thank you for watching the second episode in this series. Please feel free to proceed to the third, which is fractional exponents, and good luck on your exams.